So in this question we have a side-by-side comparison of two methods of obtaining the nth term formula for the same quadratic sequence. In the first method we look at the first level difference, which is 11, 21, 31, and of course this is not constant. So we go to the second level difference, which is plus 10, and this is constant, so we do indeed have a quadratic sequence. And since the coefficient of the term in n squared is always equal to half of the second level difference, the nth term formula begins 5n squared. Now if we look at the original sequence and identify the term numbers in red, and below it the 5n squared sequence, 5, 20, 45 and 80, we can then subtract one from the other. The original sequence subtract the 5n squared sequence gives 2 minus 5, which is minus 3, 13 minus 20, which is minus 7, 34 minus 45, which is minus 11, and 65 minus 80, which is minus 15. Now, minus 3, minus 7, minus 11, minus 15, and so on, is a linear sequence. It's decreasing by 4 each time, so we can write minus 4n, and the term before minus 3 would be 1. So the nth term formula for this linear sequence is minus 4n plus 1. Therefore the complete nth term formula is equal to 5n squared minus 4n plus 1. Now we can also use another method. We start with the sequence and we calculate the first level difference and the second level difference. Now recall the nth term formula for a quadratic sequence will be of the form an squared plus bn plus c. Now the second level difference formula, 2a, is equal to the first value that appears in the second level difference row. This is in a red rectangle. So 2a equals 10, which implies that a equals 5. And the first level difference formula, 3a plus b, is equal to the first entry in the first level difference row, which is 11. Now we know that a equals 5, so substituting we see that 15 plus b equals 11, and therefore b equals minus 4. Finally, we have the first term formula, a plus b plus c. And this is equal to the first term in the sequence. This is in an orange rectangle or square. Now we know the values of a and b, so 5 minus 4 plus c equals 2, which implies that c equals 1. And therefore the complete nth term formula for the quadratic sequence is 5n squared minus 4n plus 1.